Welcome to today's Technical Corner. Once again, I'm going to be joined by Lee Scott from the Starrag Group. We're going to be talking about aerostructure and aero engine casing machining. Now, if you like high-speed metal removal and advanced technologies, then you really do want to be listening and watching this Technical Corner. Lee, welcome to the show. Now, Starrag is well known in the aerospace industry, especially for machining aerostructure titaniums, components and aero engine casings. Why is this?
Well, that's thanks to designers and the complex shapes that need to be machined in difficult materials such as titanium and nickel alloys. Starrag have always maintained the philosophy of single setup machining and minimising tool reach, which is critical on these materials, to ensure maximum rigidity is maintained through the complete machining process.
And how do they maintain that? You know, how do they achieve what you've just said?
Well, all machines are designed with specific component types in mind, and with easy access to reach all the machined features. So from the ground up, the machines are designed with maximum stiffness and rigidity, but also they don't chatter at the kind of resonance and frequencies produced when cutting these specific material groups.
Yeah, that obviously bodes well for tool wear as well, doesn't it? There's lots of aspects to it. But what we're talking here, you're talking about aero casing, so we're not just talking about milling machines, are we? Or can they turn too?
They can do both, Paul. For structure machining, they're usually configured for just milling, but for engine cases, they're often equipped to turn as well. So, for example, the spindle bearings are automatically disengaged when turning so they're not damaged. Then we have specific turning and grinding machines in the group that can also handle driven tools. And this addition of machining capabilities brings a real measurable higher productivity for customers.
And bearing in mind the long machining times that we're talking about here with these types of applications, I mean, do you install the types of machines you're talking about with automation as well? Is that commonplace?
Yeah, and that's a great question as well, because it's a hugely growing market for us. We do sell these machines as standalones, but often nowadays they're linked to FMS systems. For example, we've got multi-machine FMS systems for manufacturing structure parts, also for manufacturing casings, and we can combine different machine types into an FMS system, such as milling machines and grinding machines or turning lathes. So we could have a Starrag and a Berthier cell, and we can also handle very large components and transfer them between machines and CMMs using rail type systems. So we have our own Starrag cell controller and tools for using the benefits of Industry 4, and on top of this we have automated systems to transfer the tool assemblies from central stores to these multiple machine FMS systems as well.
Yeah, it's fascinating, Lee. And I mean, when we talk about cutting performance as well, there's obviously various spindles achieve various cutting performances. What spindles do you offer, and what are the options there?
Well, we manufacture most of our own spindles and gearboxes, and for cutting hard metals, we have different options, but they're all optimized specifically to outperform today's high-end cutting tools that are available. As an example, just on our standard 8000 gear spindle, we can achieve 760 cubic centimeters of metal removal rate in titanium with a big porcupine cutter. And then we have even higher performance options as well. We even built a spindle recently with 5,000 Newton meters of torque. Spindles are cooled, they're equipped with displacement sensors, vibration sensors, temperature sensors, and all of these deliver really valuable information that we can react to in process. And this is crucial for manufacturing tasks for our customers.
And how would this information benefit the process then? Can you maybe talk us through that?
Well, for example, if you measure the vibration through the vibration sensor, we can detect chatter frequencies from this, and we can show you as a user the specific lines in an NC program. So we can say between line 100 and 200, you're actually detecting chatter, you may not see it on your component, but you may be getting bad tool life. Or we can predict the exact position of the tip of a long tool through the data collected in the temperature sensors and the displacement, so that when a new tool comes into play, for example, we can position that so it blends perfectly with the previous tool. And that way, in a titanium pocket or an Inconel component, you get a perfect blend, and you're not having to polish out mismatches between tools. The component looks perfect.
Yeah. I mean that's pretty incredible, really. The level and depths that you've gone to, and what data you can extract. But what are the other key features that are built into the various machines for the machining of these aerospace type applications?
Well, there are many, but to name a few, coolant's very important. So we control the ambient temperature of coolant and also the correct high pressure systems, and we deliver pressures of up to 350 bar to the right place and to the right point of cut. We have automatic self-calibration of the machines, which enables us to maintain the geometrical accuracy and help with predictive maintenance. And we have a system of automatic workpiece alignments. The machines can self-calibrate and align themselves. We've got a very unique damping system in the head of the STC machine, like a disc brake that you can apply pressure to that dampens the tool, enables very high, stable, simultaneous milling. And we cool the tables to maintain the temperature control. Obviously, temperatures fluctuate as the tables are continuously moving. The STC head itself is extremely compact and rigid. It's got carbide-coated wear parts, it's got self-cooling systems, and it's available as a 2-axis or a single-axis variant. And then we have energy-saving features that can save typically $15,000 a year in running costs that again, people don't consider, but these savings all add up. And then for turning machines, we've developed very special technologies that allow us to turn basically at twice the speed and cutting data as many competitors. And then we can grind honeycomb materials as well. So there are not many applications in casings or structures that we can't cover with a really highly optimized solution. But we always go about this together with our customers with a real manufacturing advantage in mind.
It's amazing how fast this the machining of this type of application has advanced in recent years. The specific products that you're talking about then for producing these structures and casings, what would it entail? Talk us through maybe a machine.
Well, the majority of mid-range components is covered by Starrag's STC range, and that's tables from 800 to 1.8 meters, so components up to 3.4 meters. We also have a large machine range for hard metal structures called EcoForce, which uses the 2-axis STC head, can handle components up to 6 meters so far, maybe bigger in future. Then for smaller components, we have a very rigid range of 5-axis machines built at our Heckert factory in Germany, but using the same technologies. Then we've got vertical turning and we've got vertical grinding machines from Berthier and Doris, which, as I just mentioned, offer massive performance benefits and cost savings.
I mean, I tell you what, in the last 8 or 9 minutes, we have extracted a lot of information, which I'm sure is going to be of interest to our audience. Finally, Lee, let's just summarise, in a nutshell, the benefits for the customer when they're machining the types of applications that we're talking about by using your machines.
I would say lowest cost per part is very important, and with that is the lowest consumable tooling cost, which is an ongoing saving. The highest cutting productivity, of course, more production hours availability, best-in-class reliability and availability, and that's coupled with an availability package of 95%, which is a fixed monthly fee that offers 24/7 service and spare parts, so your machines just run, and also the energy efficiency. People don't think about this, but they're all ongoing savings that you get after you've bought and installed the machine on top of the productivity.
Brilliantly, I think that concludes it. brilliantly well, perfectly well. Thanks for joining us today on this Technical Corner. It's just another perfect example of Starrag's philosophy of engineering precisely what you value. Lee, thank you for joining us today. It's been fascinating to learn about the machines involved in machining the types of applications that we speak about for the aerospace industry. Speak to you next time. Thanks, Lee. Thanks for joining us.